we will also find out the equation of diffusion equation. We will talk about the diffusion equation. Diffusion equation or diffusion is related to the Fick's law. So first we need to understand the Fick's law. But before talking about the Fick's law, we talk about the Fourier's law. Fourier's law says that, for example, if we have some object which is a cylinder and there is a heat you provide over here, there is a heat, for example, you provide heat over here. This heat will transport from this place to this place. So this phenomena will be represented by Fourier's law. Fourier's law. So Fourier's law says that the heat flux Q is proportional to minus kappa del T, right? So this is called Fourier's law. Temperature gradient, which means that the temperature gradient over here, there is one temperature, there is another temperature at some place. The difference of this temperature will create a heat flow. Similar to that, we have concentration equation. In concentration equation, when we have concentration somewhere, for example, this is concentration, and these particles will move towards right if I open this lid. Let me just explain it over here. This is one box. These are particles. These remain there, and this is closed lid. The particle cannot move towards right until I open the lid. As I open the lid, the particles will scattered in all of this container. How we represent this? This is called the concentration. Change of concentration can be represented by Fick's law, which says that we have diffusion and we have partial C by partial X. It is similar to the Fourier's law. So concentration, high concentration to low concentration, we have Fick's law, and the negative sign is due to that the particles are moving from high concentration to low concentration. So now what we have to do, as we previously saw that we have a advection equation plus partial by partial X, and there was a flux. That flux, I should write it again, partial Q by partial T, partial by partial X, and F is a function of Q is equal to 0. So this equation is the advection equation. We have to replace this function with some Fick's law. And the Fick's law says that the flux of Q is equal to F of Qx is equal to minus beta Qx. Okay, and I just simply put this flux into the advection equation plus partial by partial x minus beta partial q by partial x. When I talked about the Fick's law says that J is equal to minus D partial C by partial X. If I just say that this is diffusion process is minus beta and C is over here partial Q by partial X, then this law, Fick's law, has been incorporated over here. I just solve it. For example, here it will be partial Q by partial T beta partial square Q by partial X square. So this is the equation for diffusion problem. Whenever there is a diffusion, diffusion means that something that's spread out, then we use this equation. Beta here is a constant. It depends on the material, it depends on the uh, on the on the process, how diffusion take place. So what we have, beta is the diffusion coefficient. It can be a function of x. For example, we can write this as a function of x. In that case, beta will not come out from the derivative. Partial q by partial t is equal to, so this will become partial square by partial x square beta. It should look like this, not the second derivative, beta of x partial q by partial x. So this was all about the diffusion process. So in summary, the diffusion take place when we have Fourier's law, temperature diffuse from the object, and when we have concentration means not nanoparticles. Nanoparticle can be an example of concentration as well, but we also have uh, simple particles that actually move from higher concentration to the lower concentration. Take another example. For example, we have water, and if you put salt, and these salt particle will spread out into the water. So this is an example of Fick's law. This is an example of diffusion process as well. Thank you for watching.